Hello, my name is Bradley Alicea. I'm the head scientist at Orthogonal Research and Education Laboratory. And today I'm going to talk about the impact of new technologies on open source projects. So last year I talked at this conference. I gave a little sketch of what our group is doing in open source sustainability. And this year we've done a lot more work in this area, and it's a lot more far-reaching and consequential. This is a preprint of our activities over the last year. I'll talk a little bit about our agent-based models that we've built to understand and characterize open source sustainability. So one of the key issues here is how do we summarize open source community contributions? This is about maintaining open source community relevance and activity. So in an open source community, you usually have a series of resources, a YouTube channel, a Read the Docs repository, a GitHub repository, and maybe even something like a Maker Lab. And people are doing all these activities and they're persisting in the activities. People are coming and going. And you basically want to characterize these contributions and understand how you can make them sustainable, how you can keep them going over time. So one of the cornerstone concepts of open source sustainability is feedback. So you're usually operating in the environment of having different deliverables or maybe a prototype that you work on and you produce. And so this doesn't exist in a vacuum. There's certain things that need to be in place to make it happen. There are other things in the world, there are other competing projects or competitors in the marketplace that you need to be aware of. So this idea of feedback, we want to characterize this, and it's very fundamental to open source sustainability. So last summer we had 3 students sponsored by Google Summer of Code, and they worked on various different versions of agent-based models that characterize some of these concepts. So Brian worked on collective behavior. So last summer we had 3 students working on open source ethics. This work was sponsored by Google Summer of Code, and they each produced their own agent-based model to characterize an aspect of open source sustainability. Brian McCorkle worked on active inference and collective behavior. Hussein Ather worked on personality theory, and Himanshu Shogul worked on a reinforcement learning model of different types of contributions. So this is a very interesting set of work. It's in that preprint that I just showed you. So we can actually look at open source generative models more broadly, and we want to understand these new types of models. We want to understand the idea of keeping things under control. So if you're aware, ChatGPT and Stable Diffusion over the past year have been very disruptive to society, perhaps in the future even more so. And so we recall the work of Kevin Kelly in his book Out of Control, where he's thought about this, and this was back in the 1990s, where he thought about this concept of these kind of lifelike technologies, and that they're generating different things that we can't necessarily predict, maybe not even control, but we need to think about them in a certain way so that we can actually get a better handle on them. So one of the things in his book that he talks about is this idea of technologies of adaptation. So he talks about things like distributed intelligence, niche economics, and supervised evolution. And he argues that with feedback, these technologies will become lifelike. And so we need to treat them as such. And we need to think about these as maybe like woolly things or scruffy things that need to be refined. So you have what they call neats versus scruffies. So you have neats, which are these neat little boxes that we know how to control, we know how they work, versus scruffy technologies, which are very much on the cutting edge and aren't very well defined. And so to him, it's a matter of taking some time and figuring out how they work to design them optimally. But generative models maybe exist outside of that a little bit. Generative models are definitely scruffy, although they're presented as neat technologies. So we have to kind of distinguish the two things and see how they interact. And then we have this idea of creative destruction or disruption in the marketplace. And what these models have done is really they've disrupted a lot of things, but people aren't really accounting for the effects of this. So perhaps in 10 years, maybe our understanding of those effects will catch up with the technologies. But for now, we're left with this dilemma of having these technologies in the world without really understanding how to deal with them. And so this is the case of Stable Diffusion. They've trained their model on a very large number of data sets. These data sets have been scraped from different parts of the web, places like Pinterest, WordPress, Blogspot, DeviantArt, etc. They basically take them, they put them into a latent space, and then they make these generative models that are available under an open source license. So there are specific open source licenses for generative models, but they don't account for the data which were used to train them. So this has led to a number of lawsuits. This is an ethical issue that we have just kind of now encountered, and we need to figure out how to deal with it in a way that isn't, that disruptive. So this leads us to the ethics of open source licensing and model training. Basically, this idea of copyleft licenses that you find with Creative Commons or with software licenses, open source software licenses, meeting the training set of data that you use to build and to train your generative model. So this leads to the other thing that we're thinking about is this idea of sociotechnical problems being wicked problems. And so all open source projects, in fact, most of technology are sociotechnical problems, but there are also these wicked problems. And when we say wicked problems, we mean three things at least. The first is that they lack clarity in their aims and solutions. They're challenges of articulation and internal logic. The second is that they're subject to real-world constraints that prevent quick solutions and replication. And the third is that they're impossible to solve in a way that is simple, complete, or final. And if you look at this large picture here, you see that there's an input, and then it goes into this tangle, this trajectory, and then there are multiple solutions that come out of it. So we have an input, we have a lot of different things that come out of it, and we can't necessarily predict that black box inside that tangle. But socio-technical problems are also path-dependent problems. So what that means is that we can choose our starting point, and that can maybe inform the solutions that arise. But again, there's this issue of the butterfly affecting weather. So this idea that the butterfly flaps its wings and it can affect the state of the weather somewhere else in the world. You have the input of this forcing mechanism, and then you have multiple things that result. Sometimes you can't predict what those are. And there's a strong metaphor with generative models, especially open source generative models, where anyone can train it on different types of data and then produce outputs that anyone can prompt. So there isn't a lot of top-down control, but we still have the technology available, and the consequences are still real. So finally, different people have thought about this problem before. The first is Sinafin, which is a project management framework where they talk about these different types of problems, from clear problems to complicated problems to complex and chaotic problems. And a lot of the open source sustainability stuff that we're dealing with is in this complex to chaotic domain. There's a lot that's unknown, and maybe even more that's unknowable. And it may not seem like it because we think that it's computer science that we're designing systems, but we still do, especially with generative systems, have a lot of things that we can't control. We don't know the process behind them. Furthermore, they're collective behaviors, which we've characterized in some of the agent-based models that we were working on last summer, that have these properties. And certainly it's something to at least get our heads around, if not to come up with solutions for. So this leads us to this idea of an ethical regulator, where you can characterize the system and you can regulate the ethical behavior of people so that you can enforce behaviors on your open source participants, your users, in a way that sort of shapes their behavior. The problem with this kind of model is that it's very hard. Like I said, this is a chaotic problem in the chaotic domain. So it's very hard to define these variables that you see in these boxes. And so with that, I thank you for your attention.